Let's see how to create a job and work with CAD templates in OpenBIM BOSH. To get started, we are going to create a new job. To do this, we create a new file, select the path where it will be saved and give it a name. We can also add a comment. Once the job has been created, we can import the BOSH catalogs from the OpenBIM database, a database that is updated and provided by the manufacturer. To connect to this database, we must have registered previously. We can decide whether to download specific equipment series or whether to download all available catalogs. The program then offers us the chance to connect to a shared project on BIM Server Center. This project will be able to store BIM models that help us when defining and designing the system, such as architectural models or thermal load models. In this case, we reject this option by unchecking the corresponding box. Alternatively, the application allows us to use a wizard to generate the different floors of our building. We are going to create two floors. Firstly, floor 0 at level 0 and 3.5 meters high. Secondly, floor 1 with the same height. We keep the roof created by default. Once the floors have been created, the wizard allows us to associate CAD templates. We can select one or several files, which can be DXF, DWG, or even image or PDF files. By checking or unchecking the corresponding box, we can control the visibility of the different layers. After accepting, we access the program interface. Here, we have a top toolbar and several panels for managing the views, the visibility of the reference models, and the visibility of the different types of elements that we define in the job. We can sort these panels according to our preferences. From the 3D view, we can sort the assignment of the templates to the different floors. With the graphic reference available, we start designing the system. First, we enter the indoor units. We select an indoor unit floor fan coil belonging to a VRF system. We can choose between a 2D or 3D entry mode. We select the 2D mode with no displacements regarding our reference plane. Orientation tools allow us to define the correct orientation for each unit. With the tracking tools, we can align the various elements inserted, regardless of their orientation. Next, we choose the outdoor unit. To do this, we choose a compatible outdoor unit and place it outside. To orbit in 3D, we press the Shift key, press the mouse wheel, and then drag. To return to the previous orthogonal view, we press Alt and 4 or the corresponding button in the view panel. This allows us to easily check the correct location of the units. With the F4 key, we can activate or deactivate the visibility of the templates to make it easier to study the system. Now we connect the units with the pipe layout. In this case, we can assign a displacement on the reference level. If we have a suspended ceiling at a height of 2.50 meters, we can define a height of 2.60 meters for this layout. Next, we connect the remaining units. Tracking makes it easier to align the pipes to obtain an orderly layout. Due to technical limitations, we should not enter sections with branches shorter than 0.5 meters. The application will automatically create the vertical connections. The 3D mode allows us to verify that the layout is correct. The Copy onto another floor plan tool makes it easy to replicate the system on the top floor. The 3D view makes it easier to review the entire system. It is therefore advisable to deactivate the visibility of the templates. We then make some final adjustments. We delete the duplicate outdoor unit as well as some unnecessary pipe spans on the top floor. Then we enter a new span. To carry out this operation, we must select the 3D mode to enter the geometries. Once the design has been completed, we can carry out the analysis and checking. Our analysis will not take any thermal load requirements into account because this information is not available to us. The editing of the units shows the supplied power. We can enter this information manually and, using the Assign tool, apply it to the rest. Checks can now be carried out to verify compliance with the thermal conditions. Once the system has been defined, we can obtain the supporting documents, reports and check summaries, system diagrams and, of course, exportable CAD drawings.